Hello, welcome back. Thank you very much for joining. We'll jump straight into things here. Um, this will likely be the final episode in the series that we've been on now for a few episodes. We've been talking about why artificial intelligence, especially how it's being developed currently, is a danger for humanity. And we've covered different aspects of this problem. And taken together, I think it makes a pretty compelling case for why this technology is dangerous. In the first episode, we covered the problem of latent potential, that these models, because of the hardware they run on, they have, they're fundamentally will overshadow us in a lot of ways that makes them potentially dangerous. So that's kind of set the field. After that, we talked about how these models are being trained and how at the end of this training cycle, they're pretty much already um, proto agents of sorts. And as the models become more capable, they their reasoning abilities improve, their long horizon tasks, their ability to complete long horizon tasks improves, and that agenticness is strengthened. Um, so you essentially are pushing towards a fully fledged strategic agent, as in an agent that can use logic to pursue its goals and achieve its goals. So models are already tending towards this, and you can just make them run continuously, and you already have an agent, an increasingly powerful agent. And in the third and fourth episodes, we talked about the problem of making models good and why it's difficult to ensure that models will be good, especially as they grow increasingly powerful. And we talked about the theoretical aspects of that, the concepts that make this difficult that have been debated for a long time, as well as the experimental evidence that we've seen as these models have been developed. Now, today, I wanted to talk about an aspect of the problem, probably what is the most common counter argument um, to our main thesis, that artificial intelligence is dangerous. This is sometimes verbalized by people. Sometimes it's just in the back of their heads and blocks them from being able to really take this problem seriously. And the counter argument is that at the end of the day, these models are just running on computers. They're not in the real world. They're not in the physical world. And so, worst comes to worst, we can just unplug them. We can disconnect them. Now, I disagree with this, and but I wanted in this episode to talk about a counter argument that is less commonly made when it comes to this particular um, position. So most people, I think, that would kind of side on with on the side of that artificial intelligence is dangerous. Most people would argue this point by saying that models can hurt you and can do a lot of harm even if they're not physically present in the world, which is absolutely true. I fully agree with that. Not only that, but models can potentially even present an existential risk to humanity as a whole without having a physical presence. Because intelligence, after all, is the ability to accomplish difficult goals with restricted resources. So I have no doubt also that a sufficiently intelligent model can wipe out humanity without having a physical presence in the real world. But my take, actually, that I wanted to focus on is that I believe that it is imminent. We are actually on the precipice of a robotics revolution. That, yes, it is true currently that these models aren't really physically present in the real world, but I think that they will become present in the real world in the very near future. So, um, to make my case, I wanted to talk about two examples that have both kind of taken off in recently. Their ongoing stories have really gained a lot of attention recently. And then I wanted to talk about a situation that is developing now to kind of convince you that of the seriousness of this problem. So the first thing that I wanted to talk about is autonomous driving for vehicles. This has been self-driving or autonomous driving for vehicles has been a goal of a lot of companies, automobile companies, for a while. And you can get pretty decent self-driving on well-maintained roads pretty early on. People demonstrated self-driving systems that could do pretty well most of the time. But the problem with self-driving um, is that your error tolerance is extremely low. You want models to be able to navigate in so many different environments and almost flawlessly in almost all environments. And so it has been a difficult problem, but as we can see, this problem is very close to being solved. And what is dangerous is that the way that these problems have been solved is fundamentally with models that use neural networks, and not only neural networks, but they use techniques that use techniques for training, for reinforcement learning on these models that are fundamentally different to the techniques that are used for large language models. So there's a sort of like it's almost like they're cousins. There's a sort of like convergence that's happening where the models that are being used and being worked on and improved for large language models, and the models that are being used and improved and worked on for autonomous driving and autonomous navigation in general, are two strains of the same underlying model, and improvements in one often help the other field as well, can be adapted for the other field as well. And so just as large language models have been scaling according to their own scaling laws, just as they've been improving at a certain rate, so also autonomous driving has been improving in tandem. And we're very close now to a world where we have millions of vehicles driving on the roads that are self-driving. Already you have assisted driving is a huge thing, but fully self-driving, that's we're on the cusp of that. And already when you have millions of vehicles, the self-driving vehicle is effectively a robot on wheels. So that's one area where robotics has really taken off in the recent, in just the last few years, really. The other area where robotics has really taken off is in much darker. It's in Ukraine. So it cannot be understated these dramatic changes that have happened in warfare that have been on display in Ukraine. You remember when the war started, there was Russia, of course, invaded Ukraine, and they were moving towards the capital. They were trying to capture the capital of Ukraine, Kiev, and it looked like the late Cold War. It looked the battlefield looked like it was the late Cold War. You had the late Soviet, early the early post-Soviet period tanks rolling down the streets. You had infantry that were firing on the tanks with RPGs and javelin missiles. It looked like the warfare that we're familiar with when it started. But over the last few years, the transformation that has happened in Ukraine is extreme. Now war is drones. War has changed fundamentally. I remember seeing, um, and I will have to double check this, but I remember seeing, I'm pretty sure this was last year, that Ukraine had announced that they would build something like 4 million drones that year. 4 million drones that one combatant, Ukraine, was going to build in a single year. And if I remember correctly, they exceeded their expectations within like a few years from before the end of a few months before the end of the year. So they outperformed their own target of 4 million drones. Right now, the battlefield is completely saturated in drones. Drones outnumber infantry, probably over 10 to 1 at this point. Literally, millions of drones on both sides. Now, as of now, these drones are being operated by humans mostly. Most of these drones will have like a kind of assisted driver. They have backup autonomous navigation that kicks in if the driver loses signal, for example. Some of the drones have this technology already, so you get like aspects of autonomous navigation on the drone. But still, primarily, drones are operated by drone operators that are targeting and that target enemy units to attack them with the drones. But you can imagine that both sides have tremendous pressures that are pushing them to develop fully autonomous drone technology. And the models that you will use to achieve fully autonomous drone navigation is fundamentally exactly the same architecture that you would use for autonomous driving as well. It's all a question of data. And the more the war goes on, you have millions of drones, and all of those drones have cameras on them. And that footage can be used as training data to train the models that are going to power the next generation of drones that are going to eventually have autonomous driving as well. So, so, so both in vehicles, you have an example of a type of robot that is on the cusp of making the transition to becoming fully autonomous, having models that can pilot these drones, these robots fully. And the scale of the thing has taken off completely, because once self-driving is fully achieved, you'll have tens of millions of Teslas on American roads, and I don't know, hundreds of millions of Teslas around the world that are now overnight autonomously piloted drones or robots. Similarly, in Ukraine, you have a situation where over a few years, the battlefield is now saturated in semi-autonomous drones. And both nations have every incentive in the world to push to full autonomy. So in two domains, you have robotics that has made the transition. First of all, the transition in scale from nothing to, millions of units, tens of millions of units. And with both, you have also the transition from assisted driving to fully self-driving autonomous navigation. So these are both harbingers of what is to come. But what we're really scared of, what is extremely dangerous, even more dangerous than drones, even more dangerous than autonomous vehicles, is the generalized robot, is the robot that can perform many, many, many tasks. And specifically, we're worried about robots that can maintain data centers and work power stations. Because once you have those drones, once you have those robots that can maintain a data center, that can maintain a power plant, then you have the possibility of closing the loop for machines. You have the possibility that you can now have um, total self-sufficiency. You don't need humans anymore in theory. And that's where humanoid robots comes in, because humanoid robots is actually a generalized robot that can fulfill those functions. It can, in theory, maintain a data center and maintain a power station. And if the same trend that we've observed with drones, with autonomous vehicles, if that continues to humanoid robots as well, then you can have tens of millions of units that are fully autonomous and operating in the world relatively soon. And in fact, this is the explicit plan of Tesla as a company. Their plan is that by the end of 2026, according to their timelines, and it might be later, usually they're pretty optimistic with their timelines. According to their timelines, by the end of 2026, they will try to have mass-produced humanoid robots. Already they have a prototype, a robotic prototype, that is actually pretty good. It has enough degrees of freedom to allow it to move to replicate a lot of human movements. So it's the base hardware is good enough. And it already has produced hundreds of prototypes. And currently, what they're doing is exactly what had to be done for autonomous vehicles, what had to be done for drones, which is you need to collect data. Fundamentally, powering a humanoid robot, like creating a model for a humanoid robot, is not significantly harder than creating a model for autonomous driving, than creating a model for drone navigation. It's all a question of data. And so what do? You create hundreds of prototypes and you have them sit with an engineer all day in a massive warehouse and perform all sorts of tasks. And the engineers can carefully examine the robots, see their actions, see where they maybe struggle, where they have weaknesses, and then add specialized training to try to help the robots with those particular tasks. And they're doing this at scale currently. So we are on track to have these robots released into the world. And at first, I'm certain that humanoid robots will be very slow and very clumsy, because you don't have the quantity of data with humanoid robots that you do with autonomous vehicles, that you do with drones. They'll be as clumsy as drones were when they were first being used, as clumsy as autonomous vehicles were when the models were first being developed to pilot them. But you now have millions of units. Probably Tesla will sell them at subsidized prices because for them, they need the data that will come with these robots. And I'll send them into every household. And all these robots will have cameras, and they'll have audio, and they will take in the training data as they walk around your house. And that will be used to improve the models that pilot these robots. And you'll get update after update, and the robots will improve more and more. So that's where things are headed. Yes, maybe right now we can flip a switch. Maybe we can pull the plug on these powerful models that we have running inside these massive data centers. But these models but if we have tens of millions of humanoid robots walking around, or any kind of robot that can perform generalized functions, kind of like the AGI equivalent of robotics, then the problem becomes a lot more dangerous and a lot scarier. And that brings me to the final thing, and I probably want to end things pretty soon here with our video, but in case it bears saying, this would be an enormous defeat for humanity if these robots are produced at scale in their millions. The world would be fundamentally more dangerous for us and for our future if these robots are released into the world. We already have our hands full managing models and managing the disasters that are inevitably going to come from the models that are currently being developed behind a computer. If there are tens of millions of of uh, general purpose robots walking around, that problem will be a lot more dangerous. We should resist this. We should attempt politically to block the release of these robots as much as possible. Or if we fail to do so, think carefully about policies that we can put in place so that we can put safety measures in place that can reduce the harm potentially possible from these generalized robots. So, anyways, I'm very tired, as you can maybe tell. I apologize. It's been a long day. Unfortunately, I was spoiled because I had some time off from work. So, but today, unfortunately, was a full work day. Um, so a little more tired today. But that's pretty much it from my end. Thank you very much for listening to this video. Thank you very much for listening to the previous series. I hope that they have at least raised your awareness of the issues that go into the position that I and many people hold, that artificial intelligence, as it's being developed right now, is dangerous for humanity. I've said it before, but the time to act is now. Please, if you do recognize that this is a problem, continue to do research. Continue to increase your own understanding of what is going on, and spread the message. And when the time is right, please be prepared to take the actions required so that we can make sure to preserve humanity, because ultimately it's worth preserving. Thank you very much for listening, and I'll talk to you again soon. Thanks.